Hello friends, I welcome you in lecture number 4 on graph theory. In this lecture we are going to discuss about the handshaking theorem. The handshaking theorem is applicable to undirected graph and it is very simple result or theorem which says that if we have an undirected graph, that is the graph in which all the edges are undirected, then in that graph the sum of degrees of all the vertices is nothing but 2 times the number of edges in the graph. In an undirected graph, the sum of degrees of all vertices is equal to twice the number of edges in the graph. This is known as handshaking theorem and it is a very famous result. So sometimes they can ask you to write down the statement of handshaking theorem. So we can write in this way: let G equal to order pair capital V comma capital E be an undirected graph with edges, number of edges denoted by small e. This E is the notation for number of edges in this graph. Then sigma degree of V, where V is in the set of vertices denoted by capital V, is equal to 2 times E, where E is the number of edges. That is, the sum of the degrees of all vertices equal to 2 times number of edges in the graph. And this result is applicable even if we have multigraph or if loops are present in the given undirected graph. So they can ask you questions related to handshaking theorem or the questions which uses handshaking theorem. So we are discussing one question related to handshaking theorem, and this question was asked in GTU Summer 2020 exam. The question is: prove that there are always an even number of vertices of odd degree in a graph. This statement says that if we count the total number of vertices of odd degree, then that number is always even. That is, if we find out sigma degree of V, where degree of V is odd number, then this sum is always even. There are always an even number of vertices of odd degree in a given graph where this degree of V is odd. So this we have to prove here. They can ask in this way also: prove that an undirected graph has an even number of vertices of odd degree. So proof of this result is very easy. We can use this handshaking theorem to prove this result. So for that, first we consider two sets. Suppose capital V1 is the set of vertices of even degree. Let V1 denote the set of vertices of even degree, and let V2 denote the set of vertices of odd degree. And before that we will mention that we are considering an undirected graph G equal to order pair V comma E, and if we use these notations V1 and V2, then we can see that V1 union V2, that is going to be the set of vertices of given graph. Now by handshaking theorem we can say that if we take sum of degrees of all the vertices, sigma degree of V, where V belongs to the set of vertices, this is equal to 2 times the number of edges, where E is number of edges in a graph. So this is by handshaking theorem. Now this summation can be splitted into two summations where we consider all those vertices which are in the set capital V1 and all those vertices of odd degree which are in this set V2, and this is equal to 2 times E. So here V1 in this is this set of vertices of even degree. So now we can give this number 1. Now we concentrate on this summation. Here V1 is the set of vertices of even degree. We have taken V1 as the set of vertices of even degree. That means this degree of V is even if V belongs to V1, and here we have summation. Suppose I have V1 equal to say 3 vertices, then we have this type of situation that degree of V1 is even, degree of V2 is even, and degree of V3 is even. So this is the sum of even numbers, because degree of V is even if V belongs to capital V1, and we know that if we are adding even numbers, then their sum is also an even number. Therefore we can say that this summation turns out to be even number. Suppose we denote that even number by 2 times k, where k is a integer. Because degree of V is even for each V belongs to V1, therefore this summation is nothing but the sum of even numbers, and sum of even numbers is always even number. Therefore this summation is even number, that we denote by 2 times k, where k is any integer. So this summation is equal to 2 times k, and therefore if we are interested in this summation where V belongs to capital V2, this is equal to 2 times E minus 2 times k, and this is nothing but 2 times E minus k, which is again an even number. Now what is capital V2? Capital V2 is the set of vertices of odd degree. So here we have all those vertices which are in capital V2, and we are taking their degrees. So degree of V is odd here, and we are taking their summation, and their summation turns out to be even. So we can say that if we are adding the degrees of vertices which are odd, then this summation turns out to be even. So we can say that there are always even number of vertices of odd degree. So in this way we can easily prove this result. I have written systematically here. First we have to write that let capital V1 be the set of vertices of even degree, and capital V2 denote the set of vertices of odd degree respectively in an undirected graph G equal to order pair V, E. Then capital V is V1 union V2. Now by handshaking theorem, twice the number of edges equal to sigma degree of V, where V belongs to capital V, but this is nothing but V1 union V2. Therefore we can replace this summation by addition of these two finite sums. So here I have written sigma degree of V, where V belongs to capital V1, and here sigma degree of V, where V belongs to capital V2. Now we concentrate here. Here V1 is the set of vertices of even degree, therefore here degree of V is even for each V belongs to capital V1, and therefore this is the sum of even numbers, and hence it turns out to be even number. So that I have written here, that degree of V is even for V belongs to capital V1. Therefore sigma degree of V, where V belongs to V1, is even because the sum of even integers is even. Therefore, this turns out to be 2 times k for some integer k, and we put this value here. We replace this by 2 times k in number 1. So therefore 1 becomes 2 times e equal to 2 times k plus sigma degree of V, where V belongs to V2. Now V2 is the set of vertices of odd degree. So here we have the sum of odd numbers, and that turns out to be 2e minus 2k, that is 2 times e minus k, and if we denote e minus k by some another integer k dash, then we can see that sigma degree of V, where V belongs to V2, is even number. Therefore we can say that the sum of degrees of vertices of odd degree is even. So there are always an even number of vertices of odd degree. So here suppose we consider that degree of V is suppose for 3 vertices we have 3 odd numbers, or say 4 odd numbers. Suppose these degrees are 1, 3, 7 and 9 for 4 vertices which are in the set V2. Then we can see this is 4 plus 9 plus 7, that is 16, and that number turns out to be 20. But we can see that degree of V is odd. So we interpret in this way that if we add even number of odd numbers, here there are 4 odd numbers, we are taking even number, addition of even number of odd numbers, then that always turns out to be even number. And this is what this result also means, that sum of degrees of vertices of odd degree is always even, and therefore there are always an even number of vertices of odd degree. So this is very simple result, and the proof was asked in GTU Summer 2020 exam, and it is the corollary or application of handshaking theorem. We are simply using handshaking theorem, and we are using the fact that sum of even numbers is even, and if this becomes even, this is also even, so this must be even sum of two numbers. If this is odd, then even plus odd is odd number, therefore this must be even. So sometimes they ask this type of questions also on handshaking theorem. And this is all about this session. I hope you like it. Thanks for watching.